Hello everybody, in this video I'm going to explain to you how the Poisson distribution works. So the Poisson distribution is it's very similar to the binomial distribution. The way it operates is, what it means is different. The way it works is relatively similar. So what is this another probability distribution, this Poisson distribution? Well, it's going to be something I can apply in a situation when the thing that happens, the event that happens, within a rate. We can expect a certain amount of times for it to happen within a set interval of time. For example, let me put an example. This is how you write it, by the way. And it means that, there's this event, this variable x, that follows a Poisson distribution, where we can expect it to happen 6 times, 10 times, whatever times, I don't know. Let's call it lambda. And now let's go for an example. And I'm going to show you how you find out the probability that it happens a certain amount of times, knowing that in general it happens 8 times within that interval, 10 times, etc. Let's find out. So for example, a call center, and I have the rate of phone calls per minute as 11. That's the average. That's the normal thing to expect. And I know it has a Poisson distribution. So I can calculate the probability of there being 15 phone calls. Let's recapacitate here. I know the rate per minute, and they're asking me, what are the chances there are 15 phone calls instead of 11? What are the chances? So that's a Poisson distribution. That's exactly what the Poisson distribution is about. Here's what your Poisson distribution would look like. Instead of lambda, I have 11, and here's what I have to calculate. That's just the notation which you should use. And now let's find it. Let's find out that probability that there are 15 phone calls. All I have to do is go to my DISDR menu, my distributions menu. I think it's on top of the vars key. You have to press the blue key first, okay? So go there, go to that menu and find Poisson PDF and click on it. And just insert the values. And remember that lambda is going to be the standard rate, and x value is going to be, we want to find out what are the chances that I get 15 phone calls when I normally get 11. Press paste, just calculate it, and you get your answer. So that's it. That really is what the Poisson PDF is about and how it works. Great. So is that it? Well, let's build a little bit on this. Just not very much. First of all, an important note on something that might happen and you might have to do. Scaling a Poisson distribution. What do I mean? Well, if you get the rate per minute, they might ask you, hey, what's the rate per hour and the rate per second? Now, I'm not going to take a long time here because this is very easy. So if I have 11 calls per minute, how many calls per hour is? Well, just multiply times 60. There you go. You got 660 per hour. And now if you want to calculate anything and they ask you anything per hour, then you have to use this rate. If they ask me per second, I'm going to have to divide by 60. And again, I now get the rate per second. Very important, this is something that they might want you to do. Just do some soft scaling. And now I can adapt that rate. Great. Let's look at another thing. You might be asked to do this without a calculator. Now, it's going to be, again, one of those situations where all you have to do is put it in the formula, press enter, calculate, that's it. So there are situations where this might show up without calculator paper, or situations where it's with calculator, but for some reason you have to use a formula. This is what the formula looks like. I'm going to do it for this example here, simplified. Rather than 11 and 15, I'm just going to go for 5 and 8, but it's the same thing. Here's how you write it, and look at the formula booklet. You'll see that you have e to the power of minus lambda, and then times lambda to the power of x divided by x factorial. If you solve it, you get it, 0.065. So again, it's just a formula. You just have to put in the values and solve it. Here's what the formula looks like in general. There are situations where you might have to find out the lambda, and they give you the x, right? In those situations, it's going to be complicated to solve this equation. This is not an easy expression to deal with. most of those cases, just try tapping in some values. That probably is going to help. So again, like in the binomial theorem, we have the binomial distribution, sorry, we have again a way of dealing with cumulative probability. And again, we use a function that's not Poisson PDF, we use Poisson CDF. So here's a simple case. What is the probability of there being at most 6 phone calls? Like no 7, just maximum 6. So again, here is my expression. And I need to calculate probability that big X is at most 6. Now, at most is beautiful because it's exactly how you tap it in exactly the same way as a binomial distribution. So again, make sure you're using Poisson CDF. It's just a little bit down from Poisson PDF. And the value you're going to insert here, remember, is at most 6. 6 is okay, 7 is not. 6 is okay, 5 is okay, 4 is okay, 3 is okay, etc. That's how you use Poisson CDF. You paste it, and you're going to be able to get the value, 0.762. That kind of makes sense. There is a slight complication of the Poisson CDF, which is not very much. It's just very much like in the binomial distribution. You're just going to have to make some adjustments. Let's take a look at one example of that. So if I know they're asking me rather than at the most, they're asking for at least 6 phone calls, right? If they're asking me for at least 6 phone calls, again, I have my Poisson distribution of 5. I need to go bigger than. I need to know this one. Well, I have to realize, and this is the step that you have to get good at, that for x to be bigger or equal to 6 is the same as 1 minus for x to be smaller or equal than 5. And hence, I can get my Poisson distribution. So it's not very, I don't think this is very difficult. So just like you might have to pop back here quite a few times because this might not be that easy to remember in a 2-year course. That's the only thing that I found really relevant here. Thank you very much for your time. Thank you very much for watching. I will see you next time. Goodbye.